Chapter 4. Sequence. Section 1. Sequence. In the previous programs we wrote, there are only a few original input data. The data processed by loop code is also calculated by code according to some rules, not the original data. In practice, the original data we need to process is often a large number of data, and we need to use the concept of set. However, most programming languages do not retain the term set, but use array to represent batch data. SPL uses the term sequence to emphasize the order between batch data. Sequence and array can be understood as the same thing, only that the idiom is different, and sequence is mainly used in this book. A batch of data in order can form a sequence, which can be stored and named by a variable name. The data forming the sequence is called the members of the sequence, and the number of members forming the sequence is called the length of the sequence. In SPL, write the data in turn in square brackets and separate them with commas to get the sequence constants, such as the code in the table. A1 and A2 are sequences, where A1 is a constant cell and A2 is a calculation cell. A3 is also a calculation cell, and its result is an empty sequence, that is, a sequence without members. The length of an empty sequence is 0. However, an empty sequence is not a null value. In many programming languages, the members of an array must be of the same data type. However, there is no such requirement in SPL. Members of a sequence can have different data types, but in most cases, the sequence is composed of members of the same data type. Sequence members can use other variables or expressions. A2 and B2 can also define a sequence, but the sequence that needs to be calculated must be defined by the calculation cell, and it needs to be executed before it has a value. SPL can also use a cell range to define a sequence like Excel. A sequence of length 8 is calculated in A3. The members are arranged from left to right and from top to bottom in the order of cells. This sequence is equivalent to 4, 8, 3, 2, 5, 2, 0-5. You can access the member corresponding to a sequence number by adding the number in parentheses after the sequence variable. You can either get the value or assign the value. After execution, the cell values of B3 and C3 is 8 and 5 respectively. After D3 is executed, the fourth member of A3 will be changed to 3, which was 2 before, but the value of D1 will not be changed. When A3 is assigned, the value of D1 has been copied to the member of A3. When A3 is changed, it has nothing to do with D1. Sequence members can participate in operations, and can also refer to other members of the sequence as sequence numbers. A4 will be calculated as 7, B4 will be calculated as 8, C4 will be calculated as 0. The sequence number of a sequence member sometimes is referred to as its position in the sequence. If you click the cell where the sequence is located, the development environment can also display the value of the sequence, which will be listed as a table, such as A3 of the code. In SPL, the sequence number of sequence members starts from 1, and the reference of a member uses parentheses. In some programming languages, the serial number of array members starts from 0, and the reference of a member uses brackets. This should also be noted when learning programming language. In fact, a sequence variable can be simply understood as a group of variables with the same name, which should be distinguished by sequence numbers. Each member can be regarded as an independent variable. If the sequence number exceeds the limit, it is equivalent to referring to a non-existent variable, and the program will report an error. The above-mentioned method of generating a sequence needs to write out the members one by one. In fact, it is the same when generating sequence with cell range. If we want to generate a sequence with hundreds or thousands of members, this method is obviously out of the question. In SPL, the syntax of the expression x times n can be used to generate a sequence of length n, and each member is x. For example, 0 times 100 will return a sequence with 100 zeros as members, so we can create a sequence of any length. The sequence created by this method will have an initial value for all members. So, can there be a sequence with no initial value, just with vacant positions? In fact, this is meaningless. Any variable in a computer program will always occupy some memory space, and there will always be some data in the space. The only difference is how to interpret the data according to the variable type. There is no vacuum value that does not occupy space. The null value we usually talk about, that is, null, is also a data type. It also takes up some storage space. You can also use null times n to generate a sequence, but it is not much different from 0 times n in space occupation. In SPL, null and 0 are different, that is, null not equal to 0 will be evaluated as true, similar to SQL, but in some programming languages, null and 0 are the same thing, such as C language. We'll talk about how to generate and process a sequence with uncertain length later. Having learned sequence, we can change the previous example of calculating the Narcissus numbers and write all the Narcissus numbers into a sequence. Assuming that there are at most 100 Narcissus numbers, which are actually far less than 100, generate a sequence of length 100 in B1. A1 is the number of Narcissus numbers currently found. For each one found, let A1 increase by 1, and then fill in a corresponding member in B1. Finally, those members in the front of B1 that are not 0 are all the Narcissus numbers. Let's use sequence to implement a classic algorithm, bubble sorting. Giving a group of numbers, or a sequence, we need to rearrange the members of the sequence from small to large. The algorithm process of bubble sorting is as follows: scan the sequence from head to end. If the size of adjacent members is not appropriate, such as the previous number is larger than the next one, then exchange the two numbers. After a scan, if an exchange action has occurred, it is necessary to scan again until no exchange has occurred in a scan, and the sorting is completed. The data to be sorted is in A1. After the outer loop starts, D1 is set to false to assume that this is the last loop, and then the sequence is scanned. If the size of adjacent members is not appropriate, the exchange is implemented, and D1 is set to true, so that the next outer loop can be carried out. If there is no exchange, D1 remains false and the outer loop ends. There is another common variant of bubble sorting. Please try to understand the principle of it by yourself. With sequence and its sorting ability, we can simplify the previous problem of black hole number, and use the variant of bubble sorting to sort. Here it is to sort from large to small. With sequence, we can use loop B6 to D6 to calculate the 4-digit number. Before that, we need to fill C6 and D6 with 0, that is, the cell E2, and then we can correctly calculate the maximum and minimum 4-digit numbers through the loop of B6 to D6. In cell E2, as mentioned before, A equals X is also regarded as a calculation expression, and will have a value. D6 equals 0 will be calculated as 0 at the same time of assigning 0 to D6, and then it is assigned to C6. As a result, both C6 and D6 become 0. Section 2. Loop of sequence. With loop, we can implement some aggregation operations for a sequence, such as the previous max or mean. In cell A2, the A1.len will return the length of sequence A1. This function in the form of x.f will be discussed later, and we just let it be here. This is a standard algorithm for calculating the maximum and minimum value. For the maximum value, set the target value to a very small number, and then compare it with the sequence member in turn. If the current member is found to be larger, replace the target value with the current member, and then get the maximum value at the end of the loop. The minimum is the opposite process. The sum is also simple. However, we always need to write an A1.len, and then use the sequence number, A1, A2 in parentheses, when referring to members, which is a bit troublesome. In fact, the sequence itself can also be looped. Max mean can be written this way. 4 can be directly followed by a sequence, the number of cycles is the length of the sequence, and the loop variable is each member of the sequence in turn. There is no need to write the length of the sequence, and there is no need to use the sequence number to access members. It's also easy to write sum. In recent years, programming languages have begun to support this kind of set-type loop writing method. The early programming languages did not have a strong set concept, so they could only use the previous sequence number writing method. However, there is a problem. We don't know the loop number of the current loop. For example, when we calculate the maximum value, we want to know not only what the maximum value is, but also which member is the largest. It is relatively simple if we use the above-mentioned sequence number writing method. When we find a larger member, just write down its sequence number. Finally, C1 will be the sequence number of the maximum value. SPL has taken this into consideration and provided a method to obtain the current loop number even when the sequence loops. When a sequence loops, there are two loop variables. The loop cell itself is a member of the sequence. After adding the hash sign, it means the loop number. Here, it is exactly the expected sequence number. This variable with hash sign is usually called the loop number. Let's take another example to judge whether two sequences of the same length are identical, that is, each member of the same sequence number is the same. It can be written using a conventional loop like this. If an unequal member is found, output no, and then jump out of the loop. It can also be realized by a sequence loop. The code for this comparison can also be written in this way. After finding an unequal member, jump out of the loop and judge outside the loop. A3 code means that the loop variable still has a value after the end of the loop, and if the loop ends normally, its loop variable will be filled with the number of cycles plus 1, which is equivalent to the value of the loop variable if there is another round of loop. When using a sequence loop, the loop variable will be filled with a null value at the end of the loop, and the loop number is not defined anymore. Section 3. Multilayer sequence. The members of a sequence can also be sequences, and a multilayer sequence can be formed in this way. For example, the sequence with 2 layers of square brackets is a legal sequence, and each member is also a sequence. Let's look at how members of a multilayer sequence can be referenced. Try to execute this code and observe the running results to understand the actions of member reference and assignment of multilayer sequence. The result of A2 is sequence 456. A3 gets the second member of the third member sequence, namely 8. After A4 is executed, the third member of the first member sequence becomes 0, which used to be 3. A5 is the length of the sequence, which is 3, and A6 is the length of the third member sequence, which is 4. After A7 is executed, the second member sequence will be changed to 0, and this member will no longer be a sequence. Multilayer sequence can also be displayed on the interface. After the above code is executed, click A1 to see its value on the right. The sequence members will also be displayed as a sequence. At this time, double-click a sequence member, such as the third member pointed by the arrow. The members of this member sequence will be displayed. The sequence composed of n sequences of length m can be understood as a two-dimensional structure, and each member sequence can be written as a row, and it can be regarded as a table of n rows and m columns. Therefore, some programming languages also call a two-layer sequence as a two-dimensional array, and even have done some special processing, and can support the writing method of x, I, j in parentheses to access the member of the ith row and the jth column. There is no special understanding in SPL, it is simply understood as the jth member of the ith member sequence, that is, written as x, I in parentheses, j in parentheses. Obviously, there can be more of these levels. In terms of array, there can be more dimensions. We use the two-layer sequence to calculate the Pascal triangle. Pascal triangle is composed of n rows of numbers. The nth row has n numbers. The mth number of the nth row is the sum of the m-1s and mth numbers of the n-1s row. The nth row number of Pascal triangle is exactly the coefficient of term x to the power of I in 1 plus x to the power of n, that is. The code is simple. Calculate to the A1 plus 1th row, the result is a two-layer sequence, which is saved in B1. B1 generates a sequence of length A1 plus 1, which is ready to be filled in. C1 and D1 are filled in the first two rows. The A2 loop is calculated from the third row. B2 generates a sequence of length A2, with members all B1, for the current row, and then calculates from the second column to the A2 minus 1 column. Because the first and A2 columns of this row are all 1, it is unnecessary to calculate them. Section 4. Understanding objects. Let's take a look at an example code. The value of A1 is assigned to B1, and then B1 is changed in A3. If you look at A1, you will find that it has not changed and still is the starting value. That is, the equals A1 in cell B1 copies A1, and is irrelevant to the original A1. Similarly, the value of A2 is assigned to B2, and then one member of B2 is changed in A4. Now we can see that the member of A2 has been changed. This shows that the assignment of sequence is different from that of integer, and the assignment in B2 does not copy A2. A2 and B2 are actually the same thing. Unlike the single values of integer and floating point, the sequence is a complex data type composed of a batch of values. This kind of data will occupy a large space in the computer to store, and is not suitable to be directly stored in the memory space occupied by the variable itself, and needs special space and needs to be managed uniformly. The computer will give a number to every memory space, so that it can find the space with this number later on. This number is also called the address of the memory space, which is very similar to the address we use in daily life. For the complex data type of sequence, what the variable stores is not the data itself, but its address. The address of the memory space is also called pointer in many computer materials. Back to the above code, the assignment statement of B2 only copies the address of sequence A2, not the value. After execution, A2 and B2 store the address of the same sequence. At this time, if you change the member of B2, that is, if you change the member of that sequence, you will also see the change from A2. Similarly, if you change the member of A2, you can also see the change from B2. The simple values of integer are completely copied when they are assigned values. If you change one of them, it has nothing to do with the other. The computer community is also used to call the complex data types such as sequence as objects. We'll come across more types of objects later. An object usually has many functions related to it. For the function f with object x as the main parameter, it can still be written in the traditional form of fx. But in order to show that f is strongly related to x, we often write it in the form of x.f, and also call f the function or method of object x. For example, the function x.len that returns the length of sequence x. A large number of functions in SBL are written in the form of such objects. In the previous code, we need to know the maximum length of a sequence when we want to use a sequence. We first create a sequence with a certain length and then fill in the members in the execution process of the program. It is not convenient. We cannot always know the length of the sequence to be used in the program. For example, the number of Narcissus numbers in the previous example, maybe 100 are not enough. If it is long, it will waste space, and if it is short, it will lead to overflow error. In fact, for the sequence object, SBL provides ways to change its length, which is, to be exact, to insert and delete members. Execute the program and observe the changes in A1. A.insert ix will insert a member x before the ith position of sequence A, and the original ith, I plus 1's members etc. will move backward in turn. If I is 0, x is inserted to the end, that is, appending a member. A.insert will increase the length of the sequence. A.delete I will delete the ith member, and the sequence length will be reduced. We rewrite the Narcissus number program using insert function. Create an empty sequence in B1, and then append a member in E5 for each Narcissus number found. Finally, B1 is the sequence composed of all Narcissus numbers. The length of the sequence is exactly the number of Narcissus numbers, and there is no waste of empty positions. Pascal triangle can also be implemented in a similar way. B1 initializes the first two rows. In the loop of each following row, a sequence with only head and tail is generated in B2, added to the end of B1, and then the calculation of B2 is completed by inserting the intermediate value in B2 by the loop. Pay attention to the action of appending B2 to B1 in cell C2. When adding a sequence member to a two-layer sequence, add a layer of brackets to the parameter, that is, the B2 in brackets here. This is because the insert function actually allows a sequence to be inserted into the original sequence at a time. When x is also a sequence, A.insert ix inserts the members of x before the ith member of A in turn. If I is 0, append to the end. To insert sequence x as a whole, such as the case of this example, you need to add a layer of brackets, as a sequence with a length of 1, otherwise, insert function will take x apart and insert the members one by one. We'd like to say a light digression here. In fact, once the memory space in the computer program is created, its size is fixed and cannot be changed. The insert function can change the length of the sequence, and the action behind it is to recreate a larger memory space, copy the original members of the sequence, and discard the original space, that is, return it to the operating system. It is conceivable that insert function will be a very slow action. Frequent use of insert function will lead to continuous creation and moving of storage space, resulting in low performance of operation. Of course, the memory space will not be recreated every time. It will be created a little larger at once, and be recreated again if not enough. Therefore, we should get used to avoiding it in code. This principle is applicable to any programming language.